Okay, getting these next problems mostly depends on your ability to make sure that you have your unit circle drawn out like I have here. Or like I mentioned before, if you want to practice it by writing it out as a table, I got the degrees, I got the radians, I got the sines and the cosines to go with. Remember, this is your x, this is your y. If you're looking at the ordered pairs all the way around the circle, this is pretty small. I don't know if you can see this, but you'll have it drawn out, or you'll need to make sure that you can practice to draw it out. The first couple of problems are saying, are these angles coterminal? Remember, coterminal means when the angles are in standard position. That means you got like a central angle, vertex at the center, one of the sides is the positive direction of the x-axis, and then it goes counterclockwise, positive, clockwise, negative. If you have two angles that when you draw them have the same terminal rate, the same second side, because they're all going to have the same first side, it's the x-axis, positive direction of the x-axis. But if they have the same terminal ray, terminal side, then they're coterminal, the same, terminal. So all you have to do is take the smaller of the two and add 360 or 2 pi, depending on what you're doing, until you see either you get this or you miss it. You know, you go past it, more than it, something like that. So if I add 360, negative 500 degrees, and I add 360 to it, I get negative 140 degrees. Well, it's still too small, so I'm going to add another 360 degrees. Negative 140 degrees. Calculator comes in handy about now, because you're in a hurry. Adding 360, son of a gun, I get 220 degrees. So don't forget to answer yes. They are coterminal. Here I'll take this, the smaller one, the negative. I'm going to add 360. I didn't see any of these kinds of problems on your worksheet where they were doing this in radians. So you would do the same thing, only you'd be adding 2 pi. It's just, it'll be a pain because of probably some fractions. So this is going to give me negative 170. And if I add negative 170, still too small, I add another 360. I'm up to, looks like 190, and I go past that by 180. So no, I didn't get them to match. They're not coterminal. This is in the first quadrant, this would be in the third quadrant. Alright, although 10 would be its reference angle. Kind of weird. Now it says, find the coterminal angle between 0 and 360. So it's either going to be less than 0 or it's going to be more than 360. If it's less, you add 360 on again and again till you get between 0 and 360. If it's more than 360, like this one, you subtract 360 until you get down to a 0 and 360. So if I take negative 460, 65, excuse me, and I add 360 to it, I'm going to get negative 105 degrees, and if I take, it's still too small, take negative 105 degrees and I add another 360 onto it, I'm going to get 255, and that is my coterminal angle. Now they could ask you for the reference angle, but you would have to say, oh well, this is in the third quadrant, 180 plus, and you could figure it out. It would be 75 degrees. This guy here, too big. I need it between 0 and 360, so this time I'm going to subtract 360 from it. And again, it would be nice to have the calculator. It looks like 255. 255. And that's between 0 and 360. I got the same answer. That's a coinkydink. Alright, so anyway, 255 would be the angle. Now I put the stars next, or the asterisks next to this. I'm going to kind of highlight it here as well in green. You need to know these four. You have to just memorize them. Just got to flat out memorize them. What's nice is that if you can remember sine and cosine, you can find the other ones using this. See how the tangent theta is the sine of theta divided by the cosine of theta? Cotangent is just the reciprocal. Cosine of theta over the sine of theta. The secant and the cosine are reciprocals, so the secant is 1 over the cosine of the theta, and the cosecant of theta is 1 over sine of theta, as they are reciprocals. Sine and cosecant are reciprocals of each other. So now I have a slew of problems here. I have 12 problems. I want to find the exact value of each trig function. Notice there's some sines and cosines, but there's a lot of tangents and cotangents and secants and the whole 9 yards. The first 4, I've given you drawings of the angles. So I want the cosine of 120 degrees. So you would check your table over here, the cosine of 120 degrees. negative 1/2. The cosine of 120 degrees is negative 1/2. So this is equal to negative 1/2. That was easy. I need the sine of 315 degrees. My theta is 315. So 315 goes all the way around to here, right? The green. So the sine of it is negative square root 2 over 2. If I go down to 315, I go over to the sine, see it's negative square root 2 over 2. Okay, negative 120 degrees. I want the cosine of it. That's no good. If they give you one and that's negative, add 360 or 2 pi onto it until you get a positive coterminal, just like we were just doing. So if I add 360 to negative 120, I get 240 degrees, which is this angle this way. 240 degrees. Cosine's going to be negative in the third quadrant. 240 degrees would be down here, the cosine would be negative 1/2. 240 degrees, the cosine is negative 1/2. Okay. Now this one, they didn't have any quite like it, and I was kind of surprised that they did or they didn't, have that. But this is what I call a quadrantal angle. The terminal ray is on the axis, 180 degrees. The tangent of 180 degrees is the sine of 180 degrees divided by the cosine of 180 degrees. The sine of 180 degrees is 0. The cosine is negative 1. So this is 0 over negative 1, which is 0. Now, the tangent of 0 is 0. The tangent of 180 is 0. The tangent of 90 is undefined because you'd get 0 in the denominator. The tangent of 270 is undefined. You get 0 in the denominator. I don't know if he's going to throw any at you like that, but you could be aware of that. That's where the table or having this unit circle to look off of comes into play. Cotangent of 225. Here's 225 in green. The cotangent is equal to the cosine of 225 divided by the sine of 225. The cosine of 225 is negative square root 2 over 2. The sine is negative square root 2 over 2. This is nice. This is equal to positive 1. You have a negative divided by a negative is positive. It's the same number divided by itself. Those are the good bestest kind. The secant of 5 pi over 3. 5 pi over 3 here would come over here, this purple line, and I want the secant of 5 pi over 3, which is 1 over the cosine of 5 pi over 3. Well, the cosine of 5 pi over 3 is a half. So this is equal to 1 divided by a half, which is 1 times the reciprocal, which is 2. Now, if he wants you to put in all the tangents, you're going to have to be busy. You need to practice that as well. But I don't know if he's going to have you do that this time, because if he wants you to be able to do it in 5 minutes, that might be pressing your luck a little bit. Speaking of tangent, the tangent of 30 degrees is the sine of 30 degrees divided by the cosine of 30 degrees. The sine of 30 degrees is the square root, the 1/2. So I have 1/2 on top and the square root 3 over 2 on the bottom. Now the worst thing about this is arithmetic. You have to be careful. This is 1/2 times the reciprocal, which is 2 over the square root of 3, and these 2's cancel. So I have 1 over the square root of 3, but don't stop there. Multiply top and bottom by the square root of 3, and I get the square root of 3 on top. Square root of 3 is 3 on the bottom. There it is. The cosine is 7 pi over 4. That one's pretty straightforward. 7 pi over 4 in the green here. 7 pi over 4 in the green. The cosine, is it the cosine? Yeah, it's the x value, so it's just square root 2 over 2. All right, now, the last 4 here. Cotangent of pi over 6. The cotangent of pi over 6 is the cosine of pi over 6 divided by the sine of pi over 6. Now, pi over 6, that's this one right here in pink. The cosine is the square root of 3 over 2. All over the sine, which is a half. So this is the square root of 3 over 2 times the reciprocal, 2 over 1. Well, that one worked out real nice. I get the square root of 3 over 1, which is just the square root of 3. I don't have to rationalize the denominator there. It was a rational number to begin with. Probably going to have at least 1 or 2 of these here. Cosecant of 11 pi over 6. That's the one in pink here. 11 pi over 6, the cosecant, remember the cosecant is 1 over the sine, so this is 1 over the sine of 11 pi over 6. So this is 1 over, now the sine of 11 pi over 6 is negative a half. So this is negative a half, so this is positive 1 times the reciprocal, which is negative 2 over 1. This is just negative 2. The secant of pi over 4. The secant of pi over 4 is 1 over the cosine of pi over 4. So what's the cosine of pi over 4 in green? The cosine is square root 2 over 2. Pi over 4, square root 2 over 2 for the cosine. So this is 1 over the square root 2 over 2, which is 1 times the reciprocal, which is 2 over the square root of 2, which is 2 over the square root of 2. So I rationalize by multiplying top and bottom by the square root of 2, and I get 2 square roots of 2 all over 2. And you think you're done, except that the 2's cancel. So it just turns out to be the square root of 2. That one's really simplified. One more, it's going to be a lot like this last one. The cosecant of 3 pi over 4, which is 1 over the sine of 3 pi over 4. So that is the sine of 3 pi over 4, that's in green, is square root 2 over 2. 3 pi over 4 is square root 2 over 2. So this is 1 over the square root 2 over 2, which I think I just did. Right? Didn't I just do this? No, the arithmetic, not the angle, the arithmetic. So this turns out going through the same steps. 1 times the reciprocal, and multiply top and bottom by the square root of 2. It's 2 square roots of 2 all over 2, square root of 2. Now that's a lot of the different kinds of things that I would expect that you need to be able to do, but I'd say 50% of it or more depends on knowing your unit circle or being able to draw it out. Practice that. When you feel like you've got that, or you've got it as good as you can get it anyway, then practice these kinds of problems. Make sure. Now again, these kinds of problems, that was the worksheet from Friday. You know, you've already worked it out. Don't look at that. You've already got the work there. It's going to influence your thinking. Get the copy that's in your folder. Look off that. Do it on separate paper. Don't mess that one up. Do it on separate paper. Work every other problem, every third problem. Just enough so that you can check your work to see if you're doing them right. Or you can give me a call and I'll help you out with that. All right? Good luck with your review, boy.